Okay, so this is section 2.5. We want to look at elementary row operations as matrices. And so the textbook uses a particular notation. And so remember, our first row operation was interchanging two rows, so say row I and row J. So that they call, and they use an E for all of these matrices. So they would call this EIJ, and of course I is not equal to J. So we want to interchange two rows, and that can be done by just starting with the identity. All of these start with the identity. And so, suppose, well, let me make it even bigger than that. So suppose I have, this big identity matrix here, and it has ones down the diagonal. And then now, let's say here's row I, and down here somewhere is row J. So normally you would have a 1 here, say, going, we'll kind of make the diagonal go down like that, and you got all zeros out here, and you'd have the 1 1 1, and you'd have a 1 here. So here's our rows. 1 1 1. Okay, so you'd go to these two rows, and you just swap the rows in this identity matrix. And so this becomes, that's a 0, this is a 1, that's a 0, and that's a 1. Okay, so what happens is, so for all, if you take A, K, K, that element, that's going to equal 1 if K is not equal to I or J. Okay, so that's the diagonal element, A, K, K. And then you're going to have I is 0, so that's that element here in the diagonal, and JJ is going to be 0. Okay, so we have those two things, and then look here, so this spot here was I, and this is JJ, so this is column J, row I, and so what happens is AIJ is equal to 1, and AJI is equal to 1. And then LK is equal to 0 if L is not equal to K, so now we're off the diagonal, and L and K are not equal to I or J, like that. Well, gosh, that isn't, yeah, let's rewrite that. That doesn't look good that way. So really, I guess what I want to say is, and LK is not equal to, you know, ij or ji. So there we're actually looking at those pieces. But, you know, so it's just that in essence you swap the rows I and j of the identity matrix to make this thing. Okay, so if I have something like E 2 3 for you know, 3 by 3 matrices. Okay, it's important. I need to know how big the matrix is to fill in the rest of the stuff. Well then, you know, okay, I'm doing 3 rows. Well, the first row is untouched, but the second and third row of the identity need to swap. So there's the third row of the identity, there's the second row of the identity for a 3 by 3. And, you know, if I did that same sort of thing for E23 for 4 by well, let's see. So yeah, 4 by 4. I was going to say 4 by 5, but the matrix itself, the E, is always square. I can apply it to a 4 by 5 matrix, but the identity, you know, the identity is always a square matrix, and so we would have our 1 0 0 0. Again, then swap the third row and the second row, and then the last row is 0 0 0 1. Okay, so that is 1, interchanging rows. Then 2 is where we multiply, multiply, not very good at writing, I guess, and talking, so multiply the ith row by some t, and so that they call EI, so it's the ith row, and then they say of t. And again, you know, here t can't be 0. That doesn't make sense for our row manipulations. And so in this case, it's pretty simple. You just start with the, you know, think about the identity matrix. You got a bunch of 1s, and if this is row I, that is going to be T. And all that stuff's 0, all that stuff is 0. And so in this case, you have that AKK is equal to 1 if K is not equal to I, and then you have that AII is equal to T, and then you know, any LK is equal to 0 if L is not equal to K, so all the off diagonal pieces. Okay, so that was pretty simple. And so again, you know, if you had something like E2 of -3, you know, something like that for 3 by 3 matrices, then I've got 1 0 0 0 -3 0 0 0 1, and that's my matrix there for doing that. And then finally 3 was the adding T times the jth row to the ith row. And then, of course, the question is, well, okay, does that mean, that we're putting it then in the ith row or the jth row? Okay, Jethro Bodine. Sorry. And so they don't state that real clearly, but what we see when we look at this is we change the ith row of the identity matrix, and so this is in place in row I. Okay, so you are taking, again, that I'm going to multiply the jth row by something, add it to the ith row, and put it in the ith row. And so that matrix, which they call Eij of t, so it's important that you see the I and the J in the correct order there. What we do there, again, so here's row I. And so otherwise you got the identity coming down. Okay, but here at row I, you still have the identity. And so this thing is just the identity down like that. But then the jth column, you come over here with that jth column, go to the ith row. So we're in this row, that column, and we put our t right there. Okay, so in this case, AKK is equal to 1, so all the way down the diagonal you have 1s, and ALK is equal to 0 if LK is not the same as IJ. And then AIJ, that one element, gets T. And so in that case, something like E 2, 3 of 4. And again, for what size matrices? Well, say for 4 by 4 matrices. Well, so I'm just going to work with row 2. So it's 1, 0, 0, 0, 0, 1. And then the 3 needs to be a third column needs to be a 4. That's a 4. And then a 0. And then 0, 0, 1, 0, and 0, 0, 0, 1. Okay, so we can make those matrices pretty fast. And, let's try out, I think, it's pretty obvious these things, the first two do what they say they do. But let's just try it out on some things. So let's start with a 3 by 3 matrix, and we'll do A, B, C, D, E, F, G, H, I. And suppose we want to interchange row 1 and row 2, so row 1 gets interchanged with row 2. Then what that says is we make the matrix E12, and that matrix, again, is the identity, but with rows 1 and 2 swapped. So we have 0, 1, 0, 1, 0, 0, 0, 0, 1. And now what we do is we multiply our matrix A, so call that A, So I take E12 on the left multiplied by A, and so that is 0, 1, 0, 1, 0, 0, 0, 0, 1 times A, B, C, D, E, F, G, H, I. And notice, so this first row, what happens is I get 0 times the first row of the first column, and then 1 times the second row, and then 0 times the third row as I do that dot product. So I get 0, then D, and then 0. Add all that together, I just get D. But so you see this first row of A is just going to give me the second row, first row of E12 is going to give me the second row of A. And so the result, I'll get that D, E, F, and then A, B, C, because here, the second row, that 1 is in the first spot, so I get the first row of A. And then finally, the third row down here gives me the third row of A, so I get G, H, I. And so indeed, I did swap them. Okay, so now let's take 2 times row 2 let's do A again. So let's just start with A. And so we use E2 of, well, let's make it 3 times row 2. So E2 of 3. And that matrix, again, we just deal with row 2 and change the 1 to a 3. So I've got 1, 0, 0, 0, 3, 0, 0, 0, 1. And so now when I take that E2 times A, E2 of 3, did I write E2? Yeah, okay. E2 of 3. Our E2 again was 1, 0, 0, 0, 3, 0, 0, 0, 1. And then times A, B, C, D, E, F, G, H, I. Okay, in the first row of the E2, 3 here, just takes the first row of A, right, just repeats it, so I get A, B, C. But now the second row here, I take 0 times A plus 3 times D plus 0 times F, and so that gives me 3D. And I do that for each of the other columns. I get 3E and 3F. And then the last row down here just gives me the last row of A. And so we see that did indeed multiply row 2 by 2. By 3. 3 row 2s. Okay, and then finally, suppose I would like to take maybe how about negative 2 times row 3 added to row 2. Well, actually, let's do row 3 plus negative 2 times row 2 and put that back into then row 3. Okay, just to see what that matrix looks like. And so again, since we're putting it back into row 3, we would write this as E32 because it's very important where it's going back to and what's not getting multiplied. So it's E32 and then of negative 2 because we're multiplying by negative 2. And again, that is the identity down here but row 3 we have to mess with. Otherwise, those are the same. In row 3, it says we need to put a -2 there in column 2. Now let's take our E32 of -2 times A and see if we get what we're supposed to get. So we have 1, 0, 0, 0, 1, 0, 0, -2, 1 times A, B, C, D, E, F, G, H, I. And the first 2 rows, you know, that's just the identity working there. So the first 2 rows, we just get A, B, C, D, E, F. But then the third row, because that's where we wanted to put it back, right? We have nothing times A, but then -2 times D plus G. So that's G minus 2D. And then the next one is E minus 2H. And then F minus, oops, GH, 2H. So minus 2H. And then F minus 2I. And let's look back here. Is that what we wanted to do, right? We said take row 3 minus 2 row 2. And is that what I did? 2D, oh, I got backwards there. Okay, so I started out right. Okay, you have to yell through the video at me. I started out right, so sorry. Again, I guess I sort of just thought, oh yeah, I know what I want to do, and I didn't really do the matrix multiplication. But again, let's do the matrix multiplication. So 0 times B minus 2 times E and H. So that's H minus 2E, and then 0 times C minus 2 times F plus I. So that's I minus 2F. And whew, finally, I got that one correct finally. And there I did what we said we were going to do. We took row 3 and minus 2 times row 2 and put it into row 3. And that matrix did it indeed. Okay. So those are our row operations with matrices. So we're using matrices to do our row operations.